This data tracks performance on SWE-Bench Verified, a test of an AI's ability to solve real-world GitHub issues. For over a year, top-tier models settled at 52. By natively integrating reasoning loops, GPT-5 changes the relationship between input and output, moving from text prediction to a system that actively processes logic. Querying a trillion-parameter transformer for a trivial chat request is a massive waste of inference compute. Scaling a model to be universally intelligent while keeping it fast and affordable creates a severe efficiency hurdle. GPT-5 addresses this through a central real-time router that parses every incoming user prompt before the main processing layers. The router analyzes the prompt's complexity, tool use necessity, and system load to determine the most efficient processing path. Simple, high-volume queries are directed to GPT-5 Main, a lightweight model optimized for speed. Tricky, multi-step logic problems are sent to GPT-5 Thinking, which utilizes deeper reasoning layers to solve the task. Developers can manually bypass this automatic triage when using the API. By adjusting a parameter called reasoning effort, users can dictate exactly how much computational time the model is allowed to spend on a single problem. For low-cost or localized execution, the system also offers GPT-5 Mini and GPT-5 Nano as scalable endpoints. This architecture allows a single system to act as a fast UI tool and a heavyweight logic engine simultaneously, resolving the conflict between model size and response speed. To build the logic engine, OpenAI used a highly specific reinforcement learning protocol called Reasoning RLHF, designed to explicitly guide its logic. This training forces the model to generate explicit intermediate logical steps before it produces a final answer. This requirement for an internal chain of thought helps prevent the logical fallacies and hallucinations that often affect standard prediction models. This methodology shows clear results in the massive multitask language benchmark, where GPT-5 exceeds 90% accuracy in English. That logic remains consistent across languages, holding between 88 and 91% in Arabic and Swahili, clearing 80% in Yoruba. The domain-specific gains are even more pronounced. On the health bench medical scenarios, GPT-5 reached 46.2% accuracy, a significant increase from the 31% seen in the O3 model. The underlying transformer is natively multimodal, allowing raw visual data to be processed directly through these same reasoning layers. With a context window over 250,000 tokens, the system can apply this logic to massive datasets or hundreds of pages of technical documentation at once. Forcing the model to verify its logic step by step creates a level of expert deductive reasoning that stays reliable across different languages and specialized fields. In 2025, the AI landscape is defined by a divergence in architectural philosophies, moving away from a simple race for more parameters. This radar chart maps the current frontier. Meta's Llama 4 focuses on brute force scale, utilizing a 400 billion parameter setup and a massive 1 million token context window. Google's Gemini 2.5 prioritizes a different area, focusing on live internet integration and deep connection with Google's existing data ecosystem. GPT-5 maintains a narrower focus on structured logic and alignment, trading raw context size for more reliable reasoning. The result is a 94.6% score on the AMY math competition, a benchmark for pure logical proficiency. While competitors excel in raw data scale or real-time access, GPT-5's routed reasoning system provides a more stable foundation for tasks requiring complex execution. True agentic capability is the ability to act, observe a failure, and implement a correction without any human intervention. During internal testing, OpenAI engineers tasked the GPT-5 model with building a complete web application from a single prompt. The model planned the multi-file architecture, generated the code, and initiated a software build. When the build failed due to a compilation error, the model identified the bug in its own output, rewrote the code, and fixed the error, completing the entire cycle in 3 minutes. On the Tau bench metric, which measures this type of multi-step tool execution, GPT-5 reached 96.7%. These agentic behaviors are already moving into real-world industrial use. Amgen uses the model to navigate highly complex and ambiguous clinical data that previously required manual human review. The bank BBVA applied the system to legal compliance analysis, condensing tasks that normally took weeks into a few hours of autonomous work. Code and text generation have become foundational capabilities for frontier models. The primary challenge for developers has moved to the orchestration and management of these autonomous systems at scale. As these AI models gain the ability to continually self-correct their logic and execute complex workflows in the background, the role of the software assistant is evolving into that of an autonomous employee.